It's one thing to listen to doom and gloom about food and fertilizer shortages, skyrocketing prices, the cost of living, or your job being outsourced overseas or eliminated due to automation. It's quite another thing to hear practical, immediately actionable advice from experts who can help you reduce the fear, anxiety, and burden of these problems. Tune in now to the Surviving Hard Times podcast from the Finding Genius Foundation with Richard Jacobs. Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out, and I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on current initiatives. And now to our guest. Hello, this is Richard Jacobs with the Surviving Hard Times podcast, sponsored by the Finding Genius Foundation.
I have Laura Tew. She's what's called a county extension director in county. She's associated with the University of Florida. I don't really have how in her bio, but we'll ask her. So, Laura, thank you for coming.
Thanks, Richard. I appreciate you asking me to be on the show.
Yeah, if you would. I don't know if most folks are familiar with what an extension agent is and what you do. So, if you wouldn't mind, what's a bit about your bio and background, and then we'll get into your current work.
Okay. Well, it is a little bit complicated because you're right. A lot of people don't know what an extension agent is. And I have to go back a little bit in history to explain it. But President Lincoln in 1862, after the Civil War, signed the Morrill Act, which gave us land grant universities. And when you think of a lot of the big universities that have agriculture, like University of Florida or Ohio State, these universities were started with funds from a land grant during that period of time, and they're often called 1862 colleges. Then in the 1890s, the historically black colleges and universities, or the HBCUs that we have, were added to also give separate but equal education for African Americans. So those are your big land grant universities across the United States, and most states have two. Like we have Florida A&M University, which is our historically black college in Florida. And then we have University of Florida, which is the land grant institution. If you're a land grant institution, whether you're an 1890 or an 1862, you have three main functions. One is research, and that's why we get a lot of very high-level research out of these land grant universities, especially in agriculture, but now, of course, that has broadened to every, aspect that you can think of or at these large universities. The second one is educating students, which is where you go to get your bachelor's, your master's, or your PhD. The little known third leg of that stool is the extension service. And the extension service was signed into law back in 1912. And it basically, the government provided funding for these land grant universities to have people who would take the university to the public. So in the beginning, of course, these were agriculture colleges. So it started with people like Seaman Knapp, who was a cotton specialist. And he went out in the fields and talked to the farmers, and they had this cotton boll weevil they had a problem with. So he took that information back to the university. They did research on it, came up with a plan. He takes it back to the farmers. And that's what the traditional role of an extension agent is we are that link between a land grant university and the farmers, the producers, the businesses, and of course our clientele has expanded to the general public. My particular role is I have always been an aquaculture specialist. And so I take aquaculture research in a lot of forms that's developed by universities, and then transfer that to the public or the industry or whoever happens to need that kind of help. I'm currently a marine science extension agent because I have background in both marine and freshwater. And so I'm serving as a county extension director and a county agent in the panhandle of Florida. So a large part of my job deals with environmental education and marine issues, but I still have a significant portion that deals with aquaculture, aquaponics, and all of its variety here in Florida. So they're in a probably too big of nutshell is what an extension agent does.
Sure. Maybe we can talk about aquaponics for a little bit, or what is the difference between aquaponics and aquaculture, or is it just two different names for the same thing?
No, it's not. It's aquaponics is probably a subset of aquaculture. Aquaculture is rearing things in water, and it can be animals, plants. Of course, there's shrimp, there's fish, and sea vegetables are a big growing sector. And shellfish, of course, is growing as well, which are invertebrates. So there's a lot of different things that can be grown in aquaculture. Aquaponics is a production technique under aquaculture where you're rearing fish and plants in a closed system, and you're using the waste product from the fish to fertilize the plants in this environment where you're in a recirculating environment. So it's just one of the many production methods of aquaculture.
So is even hydroponics a form of aquaculture?
It is not. No, that's just considered a form of agriculture. That's a production method in agriculture. So I would not, aquaculture has to have, I guess, probably the fish and vertebrate sea vegetable part to it. And hydroponics is strictly just the plant. So, but that's a good question. You know, No, I mean, I wouldn't consider it in the definition, but I've never been asked that question. So that was a good one.
Oh, good. I'm off to a good start.
There you go.
I guess just a couple more terms. I've spoken to a horticulturist, an agronomist. You're an extension agent. I mean, what is a horticulturist versus an agronomist, or is it this or that, or is it just different terms for similar type things?
Well, Richard, we've spent all this money going to college, so we have to call ourselves something special. Horticulturist is a scientist that deals with plants. An agronomist typically focuses more row crop plants like your wheat, corn, cotton, peanuts here in Florida, and the relationship between the plants and the soil. An aquaculturist is somebody who deals with growing, again, fish and vertebrates and kelp now is a popular sea vegetable that's being grown. And so they're just technical names for the type of science that you're involved in.
Okay. All right. Very good. Well, maybe a few questions about aquaculture, and then we can go on to the marine aspect of what you're doing. But when you were doing aquaculture, what were some of the projects you were working on that were interesting, or what were some of the interesting things you discovered?
Oh my gosh! So I've been doing aquaculture for over 30 years. I started way back in the 80s in the tropical fish industry here in Florida, and then transitioned. I got my master's at Mississippi State. So learned a lot about catfish there, and was actually growing some largemouth bass for some, like everybody thinks of aquaculture as food fish production, but there's also a big sector for restocking natural systems. And now, of course, there's even more sectors. There's, they're growing them to replenish sponge populations, and even sea urchins are being grown in aquaculture now to do restoration type work. And after that, I actually worked at a historically Black college in Frankfort, Kentucky, called Kentucky State University. And I really hit my stride there. I was there a little over 7 years. And the researchers there, we worked on all kinds of freshwater aquaculture fish. We worked on trout. We did catfish. We did largemouth bass. We did bluegill. And we started the first freshwater prawn research there that we had brought up from Mississippi up to Kentucky. So I had the advantage while working there. I was working mostly in nutrition, fish nutrition, but I had the advantage of getting to work with multiple different species, which was really exciting. This was in the early 90s, Richard, and we were doing work on a hemp-based diet for fish, even though we had to get our hemp from Canada because it wasn't legally grown in the United States. So it's funny now to see, 20 plus years later, some of these same things coming back around. I then moved on to Ohio State, where I eventually became the state specialist for aquaculture. And the species we were focusing on there were mostly yellow perch was our big species that we focused on. But I also did work on still a lot of freshwater prawn, bringing that product up to Ohio. Tilapia, bluegill was another one that we were working on. And we were doing some pretty high level stuff. We were working on genetic selection for yellow perch, selecting for larger sizes as a food fish. And for the bluegill, we were working on all male production of bluegill using a super female technique, because a lot of fish are sexually dimorphic, which means the males and the females are two different sizes. And so with bluegill, of course, it's the male that's the big fish. So if you can produce all males and you're going for a food fish, you're going to be able to produce larger fish. This is the same thing that they do for tilapia, but most people
but when it lend itself towards not much diversity genetically in the fish, and using the same ones over and over and over, the same female to produce your line, and kind of making it, narrowing the diversity of the fish and maybe exposing them to more disease possibility.
And that's a very good point. And we definitely take that into consideration. All of the brood stock are genetically tested, and they're only matched with other brood stock that are not genetically related to them. So when you have brood stock that's that valuable, you make sure that you're not creating that type of genetic bottleneck is what I think you're referring to. So yes, that's definitely taken into consideration.
Yeah, I know with certain crops like bananas, all there is Cavendish bananas, and with rubber, there's only one kind of plant, and I just hope that that's not the way growth of various crops is going, and even with aquaculture, the same thing, because I think it could be disastrous later if they did.
Yeah. And again, it depends on what your end product is. Is your end product going to be a food product? Or, like I said, a big growing sector of aquaculture is the restoration work that's going on. Restoration aquaculture, growing fish and shellfish and sea vegetables to restore areas that have been significantly damaged. So it would depend on what your end product is what your genetics are. And we'll talk a little bit more if we get into offshore aquaculture. That is one of the requirements, that you have to use brood stock that are genetically similar to, well, they're actually identical. They're from, like in the Gulf of Mexico, the brood stock have to come from the Gulf of Mexico. You are not allowed to raise species outside the Gulf of Mexico in the Gulf of Mexico. So those things are very much taken into consideration. They're just not often talked about in the general public.
Yeah, a friend of mine is in Panama, and he said that the aquaculture has completely collapsed recently because I guess they've allowed, certain nasty organisms to get in there and essentially sicken everything. So it's, I guess it's probably a really important topic. I'm not sure how it's managed, but it came up at least in that context. So.
Yeah. I've not heard that about the farm. Was he talking about the shrimp farms?
Yeah, the shrimp and I forget what else, but definitely the shrimp. Yep.
Yeah, exactly. There are some, aquaculture is an international, it's more in other countries than it is in the United States. I mean, right now we're importing 90% of our seafood. Other countries have embraced it and grown it. The United States is kind of slower on the uptake because we have the super, super cautious principles of making sure bad things don't happen. Of course, you can't prevent bad things 100%, but there are a lot of checks and balances in place in the United States that there aren't necessarily there in other countries.
Yeah. So what's involved in marine aquaculture? What's an example of species that's grown, and how are they grown, and et cetera?
So the fastest growing marine aquaculture right now in the Gulf of Mexico and even up the East Coast is actually the shellfish industry. Shellfish, oysters, and clams. I don't know if you've been able to spend any time here on the Gulf Coast.
No, not yet.
Yeah, the wild populations of shellfish have declined. Catches are declining, just like all of our wild fisheries. They've either leveled out or declined. And so aquaculture is helping to fill that gap. And shellfish has a lot of advantages because a shellfish is a filter feeder. And so they don't have to be fed like a diet, a pelleted diet, which is one of the largest expenses in finfish aquaculture. And so these small shellfish spat, the babies, are put out in these floating cages and turned. Well, here in the Gulf of Mexico, we can raise a restaurant-sized oyster in a year, where up on the East Coast, it can take, upwards up to Maine, it can take up to 2 years, sometimes 3 years to get a restaurant size. So it's really growing here. And especially since the wild harvest has been shut down in some of the most famous oyster fisheries, like the Apalachicola oyster fishery, our Fish and Wildlife has actually closed that fishery for the next 5 years to try to help it rebound. So aquaculture farms are really growing, and the restaurants have embraced this. They're sold in all the restaurants. We're doing some work now on training restaurant staff to be able to educate their customers on, is this a wild oyster? Is this an aquaculture oyster? Where did it come from? What does that mean in terms of taste? What will it mean in terms of nutrition or health? So we have a program right now where we're going into restaurants. We just started it and educating the wait staff so that they'll be able to transition from maybe a history of only serving wild oysters to now the current reality where they may get some wild oysters out of Louisiana, but most of their product is going to be aquaculture.
So what is the difference? Is the nutritional difference, taste difference? What's different?
There's no nutritional difference. They're grown in the same water, but it's interesting. The taste difference. They sell a lot of the aquaculture products as boutique oysters. Because an oyster is going to taste like the environment it's raised in, it really depends on where the farm is located. It can bring a very distinctive taste to the oyster. If you're in an area of high salinity, you're going to have a much saltier, obviously, oyster. Where if you're in a bay where maybe you have a little less salinity, it'll be a less salty oyster. So people are really trademarking their oysters almost like you would a craft beer. They're giving them some really, really interesting names like Salty Susans. And Salty Susans come from Alligator Harbor over in Apalachicola, or Gulf Bay oysters, which comes from Pensacola Bay over, so it's really interesting how the farmers are marketing their products.
All right. So again, they grow in the same water. I mean, what does it look like? Are people lowering, let's say there's a buoy and then below the buoy, there's a line of, I don't know, porous or, like kind of bird houses type things where the shellfish can go and live and hang out. Like, what does an aquaculture setup look like in the ocean?
Yeah, that's that's an interesting visual you have there. Well, here in the Gulf of Mexico, our oysters are actually floating in net bags. So it's black net bag. It has about, I would say, a 1/4 inch mesh. So imagine a plastic net bag. It's about 3 feet long by 2 feet wide. And so it looks like a pillow, a big pillow that's on your bed. And then they put the baby oysters inside of it. They have a smaller net inside when they're small. And they float in a big long line. So you may have, 10 to 20 of these pillows, these net pillows lined up between two telephone pole type structures. And then 5 feet away, you have another line of 20. And then you have another line of 20 and you have another line of 20. So if you're on a bridge and you look out there and you see 10 lines of these black plastic, cages, oyster cages, floating in the water, that's an oyster farm. Clams, on the other hand, are down on the bottom. They sink them down and you typically don't see them. So the production method varies a little between the two species. But what the farmer does is he puts the oysters in there. He has to turn the bags, right? Anything in the water is going to get fouling on it. They have predators like oyster drills. So the farmer has to go out there and turn his crop, make sure it stays clean, make sure the size is growing properly. A lot of different chores throughout that year-long growing season. Sometimes they combine bags and do different things. So it is, there's definitely some husbandry involved in it.
Okay. So, I mean, when it comes time to harvest them, are they just pulling out a buoy with all these bags attached to it and they're magically full of delicious oysters, or what's happening?
That's right. It actually, they're using the same boats that they used when they were harvesting wild oysters, which they used to go out with these big scissor-like tongs and break off chunks of the oyster reef and bring it up on the boat.
Right.
They have these real flat boats that have the motor in the front instead of the back. And so they have a winch on the back of the boat and they hook it up to these nets because they're quite heavy now, right? They're full of oysters. And they reel it in and put the oysters on the boat. They usually have some orange baskets on there, dump them in the baskets. Anything that's not supposed to be there gets, thrown back. And then they haul them in. and there's a processing plant right on the shoreline. So they pull up to the dock. The oysters typically go into the processing plant. Oyster processing plant looks a lot like a fish processing plant. There's usually some women in there, and they have a big pile of oysters next to them, and they're shucking oysters. And then some of the oysters will go to the restaurant market. So they're not shucked. They're just bagged in smaller bags, and they're tagged, everything. There's temperature control throughout the whole process. Everything is controlled by the Department of Agriculture. Everybody's licensed and leased, and there's a big paper trail that goes along with those
what's the
oysters.
downsides, or what's the difficulties of farming this way?
The downsides are, some of the downsides we're seeing in the growth here is that in Florida, we have so much rain. A lot of these oyster farms are in the protected bays. They're not out in the open ocean because they can't handle that kind of wave action. So they're closer to shore, and they're in the protected bays. And when we get a lot of rain, we have a lot more runoff than we used to. Because of all the development and the hardscaping, we have a lot more stormwater coming off of our urban areas, which are surrounding our bays now. So that means more fresh water coming into the bay faster than ever before. And it's actually quickly changing the salinity for some of these farms. And we have had some farms that have located in areas initially and then found them to be too much fresh water, and the oysters would not survive. So that's one issue. And the farmer has had to lease another area and maybe move to an area that has better water quality.
What are some of the ways to improve their survivability, even out in the ocean? Can they go deeper? Like what is the ideal depth? And
well, these are floating. These are floating on the surface in usually very shallow areas. So usually the water is 5 to 10 feet deep at the most. In fact, they like it when the water is shallow enough at low tide that you can stand with water at your waist so you can turn your bags easier. So these are shallow waters, but it's more about the salinity that they need to get to. The other challenge is it's growing so fast. There's so many farms now, and so many people are, getting into the business that our oyster hatcheries can't keep up. The hatcheries that produce the baby oyster, that's really the high-tech part of the industry, is producing the baby oysters, getting them to reproduce, and then you get them on it's called green water because they're eating algae. So the hatcheries aren't able to produce enough spat to supply enough seed to all the farms because there's so many farms. So I hear farmers saying, I didn't get enough seed this year, or I could only plant, 3/4 of my farm. So that's another challenge that the university, through our research, is trying to help the farmers overcome.
What if you put like salt pellets in with somehow time release into each of these net bags, so that if you put it in the bay and there's freshwater intrusion, that it mitigates that? Yeah,
it wouldn't be enough. I mean, imagine, people, and salt's very expensive. Even using artificial salt in aquaculture in an indoor recirculating system is usually cost prohibitive. And you imagine in a net bag, it would immediately dissolve and go through the net material and be out of there. The volume of the water there is just way too high for that to work. But, that's how, I always say I have to come up with 10 bad ideas to get one good one. So keep thinking. Actually, the important thing is siting these farms where they're appropriate, where there is good water quality. So monitoring that water quality before the farm goes in to make sure that they're in a good quality area so that you can help negate that problem.
So is there room for a lot more farms to be put in, or is it, are all the juicy areas taken, or like?
Yeah. So all of the farms, all of the locations around the state of Florida have been surveyed and analyzed by the Florida Department of Agriculture. They are the ones that control what we call the leases. That is how you get to be able to put out a shellfish farm, is that you lease an area that has been pre-approved. So these areas have already been pre-approved as suitable for oyster culture, and they will give you a permit that you can put a farm out there. And again, you have to undergo, if you want to be an oyster farmer, there's all kinds of training you have to undergo so that you know about licenses and about temperature and harvesting and all the things. And we have all of that online. There's a lot of training available online. And so a lot of the good the juicy places, as you like to call them, a lot of those have been taken up early in the growth, but there's still plenty of leases out there. So I think there's room for more growth. And I mean, just a couple of years ago, there were no farms in Pensacola Bay, and now we have 3, maybe 4 farms over there. So that's just in the last couple of years.
Well, what's involved? Like, why all the regulation and training and all that? Like, what are farmers doing things that are deleterious to the environment if they're not?
No. It's all food safety training. So, of course, oysters, like any raw seafood product, if you ever go to a restaurant, it says eating raw seafood, you're taking your own, there are some gastrointestinal diseases that could happen from eating any raw seafood, whether it's raw tuna or even kelp or whatever. And so the time and temperature is really important for oysters. If you remember, and I don't know how old you are, but back in the day, they said only eat oysters in the months that have an R in them.
Oh, really?
Have you ever heard that saying?
No.
No. The old timers will say only eat. So this is September through March, April. Yeah. So people didn't eat oysters in May, June, July, and August. Well, that's because the water temperature is very hot. And when water temperature is hot, bacteria and other things can breed. Well, nowadays, because of the way that we handle oysters, and oysters are immediately put into the cold chain process. And again, they're timed, they're bagged, everything's marked on stickers. If you go buy a bag of oysters, it has a big sticker on it, and it'll tell you what farm that was raised on, when it was harvested, when it got bagged. All that is time stated on there. So now with aquaculture product, it has extended the season where you can eat oysters year round. Unlike,
I love raw oysters, and I go to a place and they're like, oh, we have East Coast, or we have South Bay, or we have this or that. So when oysters are located in the ocean, does it have to be that particular species that normally would needs a lot of salinity? Are they trying to match the oyster type to where it's grown, or is that not as important?
No, they are grown they're grown in the bays are connected to the ocean. It's not fresh water.
Like let's say, making this up, I don't know, an oyster in the Gulf versus one on the East Coast. Maybe the salinity is 20% more. And those oysters, are normally more salty, and that's just how they are. That's where they live. So if you put, oyster A in a different environment than it normally is in, let's say 10% less salinity or 10% more, does it mess the oyster up? Or is it still okay to grow them in places they might not normally grow?
Yeah, these are all Eastern oysters. They're all the same species that are grown all the way up the East Coast. But again, up in the East Coast, they are grown in a different environment. They are in colder water. They take 2 years to grow to size. Than the Gulf of Mexico, where they're in a warmer environment, they can grow to size in 1 year. And even up there, you may get varying salinities, because if you look, a lot of the oysters are grown in bays up there as well. And if they get too much freshwater input, they're in for the same issues.
What happens to them if it's too much fresh water or too much salinity? What happens to the oysters?
Well, you can't really get too much salinity, but too much fresh water will kill oysters.
Oh, really? Huh.
Mm-hmm.
What, osmotically, they just can't handle it and they explode or something? Or what happens to them? They die. They won't grow, and then they die. They won't feed. They won't grow. But I mean, we have, and they certainly won't grow at, the densities that you have on an oyster farm where they're all packed into a bag. So what do the oysters eat typically? When they're out in the ocean, what are they filtering through to eat?
Filtering algae. They're all filter feeders. They have one tube in and one tube out. So they suck water in and they filter out the algae, and then they spit the water and the waste out the other tube. And this is one reason people, like, if you look in terms, aquaculture is very controversial. You'll see a lot of media, pros, cons of aquaculture, and you really have to do your homework to know what you believe. But shellfish is one of the least controversial because they are so sustainable. They don't really take anything out of the environment, yet they clean the water. One oyster cleans 50 gallons of water every day. And so when you have oysters in an area, you tend to have much higher water quality because you have a bunch of little filter feeders going on. So people don't seem to mind it. We do get some pushback from the NIMBY population. Like, people don't want to look out on their beautiful bay when they just bought their, $5 million home and see these bags floating in the bay, even if they're in nice straight lines and everything. So we do get some people who object to oyster farms being in the nearshore environment, but it's more because of how they look. Most people are thrilled having shellfish as a point of aquaculture. And even some of that pushback on like the offshore finfish aquaculture, they say, let's just stick with the shellfish aquaculture and the sea vegetables. They like these organisms that feed lower on the food chain and have what they consider some environmental benefits.
What about, hypoxic zones in the Gulf or in the ocean? Legend has it there are some, and they're spreading. What happens if how do oysters deal with lower oxygen environments if it occurs?
They die. Just, yeah. What'd you say? They explode. They die also. Yeah, there are the hypoxic zone in the Gulf of Mexico, which is at the mouth of the Mississippi River. After it comes, through Louisiana and out into the Gulf. There is a big hypoxic zone. It's actually shrinking, changes. It changes, the area changes. It grows and swells. It's a moving beast. But so it's, you certainly would not want to plant any oyster farms out in an area that could be impacted by that. But we don't have that in most of the nearshore environments. That's a very offshore event, deep water. But it is a concern for offshore aquaculture. So shellfish is considered more nearshore marine aquaculture. The next stage that is coming up is offshore aquaculture, which is raising fish in pens or pods miles off of shore. And that's the project I've been working on. I've been working with a group that is putting a demonstration pod, which is a big fish cage, 17 meters in diameter, 45 miles off the coast of Sarasota, Florida, which, if you don't know, is about halfway down the peninsula on the west side of Florida. 45 miles off the coast is where it gets deep enough for this pod to go. They're going to be stocking it with Almaco jack, which is a native fish from broodstock from the Gulf of Mexico, and doing a 1-year demonstration project where they're going to attempt to grow like 20,000 pounds of fish in a year. The whole process, it was funded in part by a grant from Florida Sea Grant, which is how I got involved, because there's a huge permitting process involved in going offshore aquaculture, which is why there are no offshore aquaculture facilities in the United States to this date, because they haven't been able to get through the permitting process.
What about if, I think it's 12 miles offshore is still, let's say, U.S. water, but after that it's international. But I guess these
are in federal waters. These are in federal waters.
Gotcha.
These are still up to 200 miles is federal.
Oh, wow.
So you're talking state waters, and most places are 3 miles. In Florida, I think it's up to 9 miles, and then it becomes federal water. So these are offshore aquaculture in federal waters. So there's a lot of permitting through Army Corps of Engineers, EPA, and they're going through this process to get this demonstration pod permitted. It's not even a farm. But there's another farm called Manafish Farms that is going through the permitting process to put a farm off the coast, Pensacola. Now, the whole permitting process for offshore aquaculture in federal waters, this one demonstration pod research, they've been working on the permit for 4 years. This is not an easy process. There are a lot of hoops to jump through. There are a lot of agencies that have a stake in this. And so and since it's the first one, of course, that people are being super, super cautious, which is a good thing. And so we're putting this pod out there. Now the EPA has given their permitting. They're still waiting for their Army Corps permits. But, they had to meet requirements from the Endangered Species Act. They had to undergo siting. There were benthic studies. There's still going to be, this whole thing for the whole year is just going to be one big research project. If we put this pod out there and these fish, they're going to be researching all the parameters surrounding it, so that then we'll have that information to apply to other farms. Because doing things in a laboratory is one thing, but then being able to replicate that in a real world situation, that's the next step. And that's where we're headed.
An idea came to me. What about, with the bags that the oysters are in? What about if you could grow certain, water plants in there, in the bag with that, or on the outside of the bag? Could you put seeds in there somehow and grow plants so that there's kind of a microenvironment created for the oysters in the bag that would be beneficial to them?
Yeah, so there's also another production method that they're exploring called multitrophic aquaculture. And this is where you do exactly that. You have a couple of different types of aquaculture going on in the same area, and they synergize with each other. So they're getting ready to put one in Mobile Bay. They have one on the East Coast, I think in New Jersey, but I'm not sure. But in Mobile Bay, it's a fish cage. They're going to be raising fish, and then they surround that with oysters. So the oysters filter the water that the fish are pooping and eating in. And then outside of that, they're growing sea vegetables on the outside. So they're growing 3 different crops in one system, and that's called MTA, or Multitrophic Aquaculture. It's been experimented with a lot in other countries. It works on a very small scale. I haven't seen it ramp up to commercial scale. Very similar to aquaponics. Aquaponics, you have to know about fish and plants. So you're looking at 2 different types of husbandry methods. Well, now in multitrophic aquaculture, you have to know about fish and oysters and plants. And so it seems always a good idea in theory when you can synergize things, but sometimes in application, working with just one makes it more feasible.
Well, I was just picturing these black nets laying on the surface of the water, and you said some people complain, but if they had a few plants impregnated into them and the plants grew into the netting, I don't know. I just wonder, then you're not really dealing with other fish. Let's say maybe the fish would eat the plants. I don't know, but maybe that would make a better environment for the oysters that are sitting there. I don't know.
Well, it would be hard for, it's first off, you'd have to have plants that can grow in that environment, and then their roots might wrap around the oysters and they can't open up and filter. I could see some problems, and you have to turn the bag, so then the plants would be underwater.
Oh, okay. So
keep thinking, there, Richard. You're on bad idea number 3. You're getting close to my 10 mark.
Right. Well, so what do you see as the future of this? The oyster and other shellfish aquaculture. Like, where is it heading? You think in the near term, in the next couple of years?
Oh, I think it's going to continue to grow. We've got programs now in the high schools. Where kids are getting interested at an earlier age. There's in the FFA and the tech schools, they're offering opportunities for kids to work around the oyster industry to help it grow. I think with the offshore aquaculture, I think we're going to get this pod stocked. You're going to read about it early next spring out of Sarasota. And I believe that more farms are going to be coming into the Gulf of Mexico. And I think it's high time that the U.S. got on board with aquaculture, because it's not replacing our wild fisheries. Our wild fisheries are sustainable, but demand is increasing. So the only way the demand is going to be met is through aquaculture, because our wild fisheries are not going to increase. We have to meet increased demand through either population growth or people changing their diets to incorporate more seafood for health reasons. That growth is all going to come through aquaculture. So even though it's controversial and some people don't like it, I think a lot of the pushback is from people having outdated information about aquaculture. And I think if they took the time to research it, they would feel more comfortable with where the industry has evolved over the past 20 years.
Okay, very good. Well, Laura, what's the best place for people to find out more about your work and propose their own good or bad ideas to you?
Well, you can check out the Florida Sea Grant website, and that is 3 different words, Florida Sea Grant. We have a nice website with lots of links to all kinds of information, including those shellfish culture classes, which are free online. Anybody can take them, even if you don't want to be a shellfish farmer and you're just interested. And people can also send me an email. I mean, I'm an extension agent. My job is to educate. So if you put my email on the podcast notes, I will answer as I'm able.
Thank you for coming on the podcast, Laura. I really appreciate it.
Thanks, Richard. I had a great time.
Before you stop listening, ask yourself, what are 1 or 2 useful things you heard on this podcast that can help you overcome food and fertilizer shortages, skyrocketing prices, the cost of living, or your job being outsourced overseas or eliminated due to automation. Please like and subscribe and tell your friends and family about their Surviving Hard Times podcast. We're all going to need help now and in the near future.